Hello everybody and welcome to section 4.3. This is all about congruent triangles. Let's get some language down first. When we say something corresponds to, it refers to the matching of the side, vertex, or angle of a triangle. So corresponding, it's in the same location, the sides, the vertex, the angles match up. Congruent triangles. Congruent triangles are triangles that are in the same size and the same shape. They are congruent. Those two things have to be in place, the same size and the same shape. You can safely say two triangles are congruent. We're going to be using this acronym in a lot of proofs. CPCTC simply stands for corresponding parts of congruent triangles are congruent. So if two triangles are congruent if and only if their corresponding parts are congruent. And that's what CPCTC refers to. If you know they're congruent, then all their corresponding parts will also be congruent. Here's some properties of triangle congruence. It says congruence of triangles is reflexive, symmetric, and transitive. Reflexive meaning, okay, if I have congruent triangles, they are congruent, the same triangle is congruent to itself. That is the reflexive property. Symmetric, so down here if I have triangle JKL down here and a triangle PQR, I know that they are congruent. Then I can flip them around and I could say it PQR is congruent to JKL. That's the symmetric property. It just reverses the order in which you say something is equal or congruent. Transitive, we got three triangles here, JKL, PQR, and XYZ. I'm going to tell you that JKL is congruent to PQR. This triangle here is congruent to this triangle here. Then I'm going to tell you that PQR is congruent to XYZ. This triangle here is congruent to this triangle here. Then if that is in place, we can safely say that JKL is congruent to XYZ. That's this triangle is congruent to this triangle. And that transitive property that we've talked about, you always need a connector. In this case, this middle triangle is connecting its congruence to the JKL and the XYZ. Therefore, we can safely say triangle JKL is congruent to triangle XYZ. Okay, we'll talk about some transformations. Identifying congruence transformations says in the figures below, triangle ABC is congruent to triangle DEF. If you slide triangle DEF up and to the right, triangle DEF is still congruent to triangle ABC. So there's these transformations where we actually move or twist or turn the triangles. What we're saying here is triangle DEF has we slid it, and it kind of made this new triangle D prime, E prime, F prime, just in a different location. You can kind of think of it on a coordinate plane being in a different location, but it still is maintaining its congruence to triangle ABC by the notations here. We also go on to say the congruency does not change whether you turn triangle DEF or flip triangle DEF. ABC is still congruent to that. So here's a turn. Notice how DEF was turned. We just moved it around to a different location. It seemed to be turned around. Just everything's still matching up. And then here we have a flip, where we flipped or reflected it over a line or another place. So it's like it's looking in a mirror here. Okay, you can sort of think of a turn as a rotation and a flip as a reflection. If you slide, flip, or turn a triangle, the size and shape do not change. These three transformations are called congruence transformations.